I'd like to introduce Roger Ford. Roger is a principal product manager for Oracle Text and JSON, the database. And Roger, that's something new I didn't know about you. You've been with Oracle for 33 years. That's fantastic.
Yeah, it's quite amazing, isn't it?
Yeah, it goes by fast, doesn't it? And he's worked in support and technical marketing and product management, so we're really lucky to have him at Oracle.
Good morning, good afternoon, whatever it happens to be in your time zone. It's a scorching hot day in the UK at the moment. So, so hot that my laptop overheated and I had to move onto my desktop. So I hope everything works okay through this. I think I've moved everything I need over here, but if something goes missing, I'll let you know. Anyway, today we're going to be talking about text and JSON. So the idea of the workshop that we'll be talking about towards the end is to produce a microservice that can do searches, full text searches and recommendations within JSON data. But in order to cover that properly, I need to give you a bit of a background about Oracle Text and JSON in the Oracle database. So this is our Converged microservices, Converged database microservices slide, and we're doing that step 2 in there. Text and JSON data search and sentiment analysis. So this is about how we can make good use of the textual or JSON resources within our database. So first of all, I'm going to talk about full text. Now, as Tavi says, I've been at Oracle for a long time. When I first started at Oracle, very few people were familiar with full text searching. It was a bit of an esoteric concept, really. Since then, everybody's used to that. Everybody uses Google, everybody uses search engines in websites and so on. So we're all very familiar with the idea of being able to search for keywords within text, particular words or phrases within a block of text. So that's great. We're all used to using it, but are we making the most of it? Most companies have huge amounts of textual information scattered around all over the company. Maybe it's in email files, maybe it's in Office documents, PDFs, Word documents, etc. All those PowerPoint presentations. And there's a lot of textual information out there, and people just aren't making use of it. They don't have the tools or the power to do that searching, or perhaps they do. In many cases, they have the Oracle database. They could be using Oracle to do full text searching on all of that data. So we're going to see how we would do that within the database and why we think you should use Oracle for that rather than maybe a separate search engine of some sort. Okay. The other aspect of my talk today is JSON development. Why would people be interested in JSON development? You've got a database, you've got SQL. Surely that's good enough for everybody. Well, SQL is a wonderful, very, very powerful language, but it takes a certain level of knowledge to use it. And there is the fact that you need a predefined schema with standard relational tables. You need to know what sort of data you're going to be dealing with before you can put it into the database. So if you want to change that schema, then it's often quite difficult. You know, you've got to go to your DBA and say, oh, I need another table to store this information. And he's going to go, oh, really? How much storage do you need for that? Blah, 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 blah. So if we use JSON, it makes it a whole lot easier for that because you don't have to have your schema defined in advance. You don't have to know exactly what types of data you're going to be putting into your tables. So it allows this schemaless, agile development style, as it says. Another way of looking at it, rather than schemaless, is schema later. Yeah, you can get a schema out of it, but you don't necessarily have to know that schema before you start. So you can start off with a small type schema. You find that you need to add something to it, no problem. You can just add new values into your JSON. That's a very straightforward development model. So we have lots of ways of accessing JSON in the database. You can access it using SQL if you like. You can use a QBE, query by example method, which simplifies queries. And we'll see that later you can use something we call Soda to provide an easy API against that data. The textual values in the JSON can be full text indexed in much the way that we would index plain text in the database as well. So let's have a look at that. How do we actually create a full text index on data in the database? If it's plain text in a CLOB column or a varchar 2, then we can create what's called a context index, an Oracle text index. And that's pretty straightforward. You use the same syntax that you'd usually use to create an index, and you add this extra phrase at the end: index type is ctxsys.context. That tells it to create a full text index on the contents of that data, and then you can query it using the contains keyword. So we're saying here where contains the column name and the search terms that we're looking for. In this case, it's a phrase search, so we're looking for the words hello and world, one following the other in that order. But of course, we can do things like hello and world, hello or world, and many other more complex queries. So that's the basic default index creation and searching. There are, of course, many different options that you can apply to that, but that's the simple default. For JSON text, we use a slightly different syntax. We can actually use the contains clause as well, but more normally you would create a search index on the JSON, and that's got what's known as the simplified syntax, where you just say create search index. Later we will be moving to that for context indexes as well, but for now this is just the JSON syntax. So it's create search index, index name on table, and then the JSON column name, and then the keywords for JSON. And the way to search that would be to use the JSON text contains keyword. And here we're telling it that we want to search the JText column. We want to only look in a particular field called description. And within that, we want to search for the words hello world again. Okay, so two ways of doing it, depending on whether it's plain text in a varchar 2 or CLOB, or JSON text. Right, so Oracle text can do a whole load of other things other than plain simple keyword searching within an index. We have a number of machine learning capabilities. So we integrate tightly with Oracle Machine Learning, or advanced analytics as it was. And within using those technologies, we can do clustering, classification, and sentiment analysis. So clustering is about grouping documents together based on their shared attributes. So all the documents about a particular topic that share words that are relevant to that particular topic will be grouped together. But the system decides how those groups are assigned. So you don't get to choose that, but the system does. Classification is a little bit more sophisticated. That's where you tell it that you want to group particular topics together. And in that case, you give it a training set, and you say, here's my set of documents that are about, let's say, USA, and another set of documents that are about Mexico, and another set of documents that are about Europe. And it will look through all those documents. It will learn to recognize documents that belong in those particular sets. And then in future, when you give it another document, it will tell you that that document belongs in one of these sets that you've defined before. Sentiment analysis is great for handling things like reviews. We can tell whether those reviews are positive, negative, or neutral. So how do our customers feel about us? You know, are they submitting good reviews or bad reviews, or somewhere in between? And something that we can do that a lot of other people can't do is sentiment analysis based on a particular topic. So if it's a restaurant review, it might be very positive about the food quality, but it might be fairly poor about the level of service. You know, the food's great, but I wish they'd deliver it more quickly. And this way you can say, well, I want to know what the service is like. So are people giving me good reviews on the service, or are they saying that food quality is good but service is poor? And that sort of thing can be answered really easily with the sentiment analysis. Okay, so a bit more about JSON. JSON documents in the database, they are stored in database tables, and they can be queried, searched, updated within those tables, and they can be generated as well. So you can take your SQL documents and you can generate JSON from those SQL documents. And we'll see an example of that in a little bit. So where are they stored? They're since 12c, we've had JSON capabilities in the database since 12.1. And we can use a varchar, clob, or blob data type then. And the next major release is going to come up with a binary JSON data type. So that will be a very efficient binary format that allows for individual updates of very large documents without having to change, without having to write the whole document again. And it will allow very quick navigation of documents because it can jump through an index to the element of a particular document. Okay. So given that we've got the JSON in the database, we get the schema flexibility of the JSON, but with all of those strengths of the relational database that you're used to. We get the ACID transaction model. Some other systems claim that they do transactions on JSON, but if you look a bit more deeply, then the transaction model is perhaps certainly not as strong as the Oracle one, let's put it that way. SQL JSON standard. This is a standard agreed with IBM. I think I covered that on another slide. So that allows us to do querying of JSON within SQL queries. Okay, let's move on. So you can now treat the Oracle database as a document store. Not just a relational store, but a document store as well. It's easy to insert collections of documents or collections of JSON data and put them into your database. That means that all of your text and JSON assets are living alongside your relational assets in the Oracle database. So what benefits does that give us? Oh, hang on. That slide wasn't meant to be there. I beg your pardon. That slipped in from somewhere else. Okay, so should talk a little bit about SODA. SODA is the Simple Oracle Document Architecture, and this is a method of accessing JSON in the database without having to use SQL to access it. So SODA allows us to talk to the database as though it was a pure document database. It gives us options to create collections, a group of JSON documents, to drop collections, to add new documents to those collections, and to query those collections to find documents that match particular scenarios. So we've got JSON documents stored and managed in the Oracle database, but of course we can still use SQL to query them. Since SQL has the ability to understand JSON via SQL JSON, that means that as well as our applications communicating via SODA, we can also do direct access to the data within JSON from SQL. So that gives us all the power of the analytic capabilities of the database through SQL, as well as the simple document API of SODA. So a little bit more about JSON querying from SQL. So first of all, you've got the simplified syntax. This is the easiest way to access JSON from within SQL. So I can simply say I've got a table called purchase order here, and I've given it an alias J there, and I've got a field called PO document within the purchase order table, and that contains JSON text. And within the JSON text, there's a field called PO number. So by just using the simple dot syntax, where a table alias dot JSON column name dot JSON name is equal to a particular value, then that will fetch back all of the rows that match that criteria. I can do more sophisticated queries. I don't really have time to go into this in full detail now, but JSON table will allow you to extract JSON into a tabular format So effectively, you're treating a big group of JSON values as though they were a relational table. So that's a very powerful capability. And then we've got the JSON generation capabilities, where I can take some relational values from a relational table, in this case customers, standard relational table, and I can generate JSON text from that relational table. So you can see that we've got the ability to go both ways. We can go from relational to JSON and from JSON to relational. So yeah, JSON, SQL JSON standard, this has been agreed with IBM, so it's an open standard. It's not restricted to the Oracle database. And it uses the JSON path language, a very powerful language for navigating to specific parts of the JSON document. Okay, this is a more deep dive into JSON generation, how we can embed an array into a JSON document. I'm not going to try and cover that in full detail now, but suffice to say that there are some very powerful capabilities. Here we're using the JSON array ag operator to produce an array from relational objects in a table. Okay, so JSON indexes. There are two basic types of JSON index. I'll leave geospatial aside for the moment, but we can have a functional index, which is a specific field within a JSON document. That's an extremely fast and powerful way of zeroing on a particular value within a JSON document. But that does require you to actually know what your JSON document looks like. You can't create an index, a functional index on something, if you don't know what's going to be in your JSON in advance. So we also provide this search index, which is an extremely powerful index that indexes everything within your JSON document. So it will allow you to do an index lookup on any value within that JSON document. And it also supports full text querying, which is what we're going to use for our microservice demonstration. So let's skip on to that. JSON data guide. I've talked about the fact that you may not know in advance what JSON is stored in your table. Well, the JSON data guide allows you to find that out. It allows you to analyze all of the JSON in the table and get a listing of the layout, the schema, if you like, of the JSON in your table. It will also allow you to create relational views on the JSON in your table. So that's extremely powerful as well. And it can derive virtual columns as well. So you can then access the table by referring to it as a virtual column. So we can see an example on the right here. We've done an analysis. We've created a full text index, a JSON search index on our reviews table. And we've told it when we created the index that we want it to generate a data guide. And then we can use this dbms JSON.getIndexDataGuide to extract the layout of that JSON. This is obviously a very truncated output, but we can see that the maximum length of any of the values is going to be 8192, and that maximum length of any JSON value in there. JSON documents, I should say, rather than JSON value. And then within our JSON documents, we've only got two different fields called text and stars. The text field is a string with a maximum length of 1024, and the stars is a numeric field with a maximum length of 4. Okay, so that's great. You know, you've got a database that can handle JSON. You've got a database that handles text. There are other products out there that can handle JSON and text as well. Why shouldn't I use them? Well, you could. MongoDB is a great JSON product. Elasticsearch is a great search product. But why use 3 different engines? One for your JSON, one for your relational data, and one for your full text. You can put it all in one place. You don't have to worry about the complexities of replicating data from one place to another. You just have one source of truth. You have no problems with transactions because all of your data is in a single database. There's an estimate from the analysts that integration soaks up 30% of typical project costs. So by using Oracle to store all of your data types in the Converged database, then you can avoid a large chunk of expenditure in terms of necessary integration between all these different systems. You don't have to learn, your developers don't have to learn multiple interfaces, your DBAs don't have to learn how to handle multiple different database storage systems and so on. So put it all in one place. But you say, maybe I want to keep my stuff separate. Maybe I want to store the JSON somewhere else. So yeah, well, if you want to store them separately, then that's easy. You can use the multi-tenant capabilities within Oracle. So you can perhaps have one tenant, one PDB to store your relational stuff, another tenant to store your JSON, one for your text, or maybe one that stores a combination of all 3 as well, and then separate ones for relational, JSON, and text if you want to. So you've got the option. You can have lots of different PDBs, each with their own different types of data, or you can store them all in one place. Okay. Okay, so we're now going to talk a bit about the workshop which is associated with this. Now, I can't go into full detail about this now, but I would refer you to that URL, which I'm sure Tammy will be sharing within the materials for the workshop. If you go there on GitHub, it will talk you through all of the steps that you need to do to get a microservice created from JSON in the database. Now, we are using a full text index on some JSON text. Now, this will allow us to do a search like, for example, show me all the reviews for restaurants within a range of zip codes beginning 9160. Now, I realize that's not probably the best way to do a search like that. It would be better to use spatial, but my workshop doesn't cover spatial. That's covered in a separate one. So when you've done both of those workshops, you'll be able to combine the 2 together, and you could then do spatial full text searches if you want to. But for the moment, the aim of our simple microservice is to give you something that can be called over a REST API, and it will return a list of the restaurants within a particular range of zip codes that mention some particular terms, such as great sushi. We're going to work with the YELP dataset, and it will all be done using Oracle Cloud Services. There's nothing very complex about this at all. It's going to use basically 2 tools. You're going to create an autonomous database, and then you're going to use SQL Developer Web, and you're going to use Oracle Application Express. Those are the only tools that you need for this workshop. We're not going to be using OK or Kubernetes or anything. Obviously, you could do, but there's no need for them for this simple demonstration. So just a bit about the YELP dataset. YELP, it's a Google-owned system for business reviews. So it covers all sorts of businesses, not just restaurants, but shops, gyms, other stuff like that. It is publicly available, but you do have to agree to the license terms before you download it. So unfortunately, we can't just make it available on our website. You do need to download it from YELP. There's quite a lot of data in there. There are 8 million reviews from around 2 million users, covering 200,000 businesses. The overall size of the data is about 8 gigabytes, I think. So just a note, you can't zip through this workshop. Some of the steps take quite a long time. I think probably the longest step is creating the JSON search index, which takes around 25 to 30 minutes. So it's something that you can do a few steps at a time, but maybe stop off, have some coffee, do something different while it's running the longer running parts of the process. So the steps are as follows. We're going to go into a little bit more detail of each step after this, but as a run through, first we have to upload our JSON files to Oracle's object storage. Then we create some tables in the database. We copy the data from object storage to those database tables that we just created. Then we create indexes on the JSON. We run some queries against that JSON. Once we're happy with our queries, that the query does what we need to do, then we use Oracle Application Express to create a simple REST API on those queries. And that REST API is effectively our microservice. Right, okay, so we start with Lab 2. Lab 1 is just logging into the cloud system. So Lab 2 is uploading to Oracle Object Storage. Now, you could do this you could load directly to the database without using object storage. If you did that, you'd need Oracle Instant Client on your PC, Mac, whatever, and use that to upload, given that you have a wallet through your autonomous database. We're not going to do that, so we want to do everything using online facilities with nothing on the client. So first of all, we do an upload to the object storage. So 3 steps in that are, firstly, downloading the YELP dataset. As I say, it's about 6 to 8 gigabytes, so that'll take a little while depending on the speed of your internet connection. Then we go into autonomous database or Oracle Cloud Services, and we create an object storage bucket, and then we can simply drag and drop our downloaded YELP dataset files to the bucket. It comes as a zip file, so obviously we'd need to unzip that first. But once we've unzipped it, we can just drag and drop the files directly to the object storage bucket. The next step is loading the Oracle database from object storage. So first we need to provision an autonomous transaction processing database. So that's very straightforward. You have to give it a few details like the name of the database, a password for your administrative user, and that's pretty much it. So you do that, you create the ATP, Autonomous Transaction Processing Database, and it takes around a minute to provision. Then we can connect to SQL Developer Web, which is our web-based version of SQL Developer, an easy way of developing SQL applications through the web. And we use that to create a new user. Then we'll log into SQL Developer Web as a new user, and we create 3 tables to hold our JSON. So that's quite straightforward. This is the businesses table. We have businesses, users, and reviews. So we create 3 tables like that, and then we use dbms cloud.copydata to load the tables from object storage into the database. And that's it. We then have JSON in the database. In this case, the table would be called businesses. The column containing the JSON would be called JText, and then we can access that as necessary. The next stage is creating indexes and basic queries. So we need 2 different types of index here. So we have functional indexes for specific values, and a search index that's going to give us our full text search capabilities. So the functional indexes are needed to join our tables, because we saw that we had reviews, users, and businesses. So we need to combine them into a single search, and we'll see how we do that in a query in a bit. But in order to support that search, we need functional indexes. Otherwise, we end up doing a full scan on the JSON every time we want to match a business with a review or a user with a review. Okay, so step 1 is create search index, functional indexes, and step 2 is creating the search index. So once we've created those indexes, we could use SODA, Simple Oracle Document Architecture, to do our queries, but we're not going to do that here. We're going to use SQL to query our JSON within the system. And then step 3 of this lab is querying. We're going to create some simple moving to complex queries. And we'll see that over here. So a simple query on one table. So we're looking at the reviews table, and we want to find all the reviews where the text of that review mentions great sushi. So we covered this JSON text contains earlier. It's very straightforward. We tell it the column we want to search, the JSON field within that column, which in this case is text, and the search terms that we want to look for. This is a phrase search saying I want to find the words great and sushi next to each other in that order. And the output that we're getting from this query is the user ID who made the review and the text of the review. So that's great, but we've only got a user ID. We really could do with a user name. We want to see the user's name rather than their user ID. So that brings us on to a join. This time we're searching for u.jtext.name. So that's the user's name within the JText field, alongside the r.jtext.text, the text of the review. That's a table alias there. And we're doing the same JSON text contains. Okay, we're looking for sushi rather than great sushi in this case. And then there's a join condition at the end. We're saying that the user ID in the users.jtext should match the user ID in the reviews. Now, remember, these are not relational columns. We're doing a join directly out of values which are in that JSON text. So because we created a functional index on that, that join is going to be really fast, and this query is going to execute very, very quickly. Okay. And then the final query that we're going to do from here is a full table that joins all three of our, a full query that joins all three of our tables, users, businesses, and reviews. Okay, so reviews, users, businesses are U and B. We're fetching back the username and the business name, and we'll note that the field name within the JSON is the same in both of these cases. It's just called name. If we did that query without any column aliases, then when we got that back, it wouldn't be immediately obvious which of the tables that came from. And in particular, it might cause issues later if we're extracting this output into something else, like, for example, into Apex, as we'll be showing in a later stage. So by giving a column alias, that makes sure that when it comes out, the username is different from the business, distinguished from the business name. And then we've got JSON text contains again for sushi, and we've now got two join conditions here, so that the reviews table is joined with both users and businesses. And something I forgot to mention, we're also including the postal code search in here. So we're saying we only want to fall back documents which have a postal code like 8911%. And again, this is buried value in the JSON text. So it's not a relational column, but we can effectively treat it like a relational column just by using this easy dot syntax. Okay, the final stage of the lab is creating a RESTful interface. And this is incredibly straightforward. I must admit, I was quite new to this myself. I was looking for ways to put a RESTful interface over a text query. I thought I was going to have to write lots of code, and somebody said, Apex will do that for you easily. It requires pretty much no coding whatsoever. You go into Apex, you go to the RESTful services, you create a module with a name, you give it a template name. It provides you with a URL, and you can then add get and put handlers to that template, and they are just attached to the URL. So there's two different ways we can do it. We can either use a simple query, which is pretty much what I showed you on the previous slide. We can plug that straight into Apex, and we can get a RESTful API out of it. Or alternatively, if we want to be a little bit more sophisticated and have more control over the JSON that's generated by Apex, we can provide a PL SQL procedure, which allows us to have more control and return different types of JSON values in that. So let's take a look at that. This is in Apex. We go into SQL Workshop. We go to RESTful services. In there, we create ourselves a module, and we get this URL given back to us. We plug in our query here. In this case, we've told it it's a collection query. As I say, the alternative is to have a PL SQL query, but we're telling it it's a collection query. We plug in our SQL text. The only difference from what I showed you before is that this SQL text has a couple of bind variables in it. So where before I had sushi, here we're using a bind variable query terms and another bind variable for the partial zip code that is going to be provided. And we can call this URL. We can do it from our browser if we want, but normally it would be called from some sort of REST-aware application. And we just call that URL there and put question mark query terms equals sushi ampersand partial zip equals 8911 or whatever. And that's it. If I look at the next slide, this is the output that comes back. I was using Firefox here, which formats the output nicely when you get it back from a REST call, and it shows this is a search on great sushi, or wonderful sushi I searched for here. So a review by Denise of the business, Hanabi Sushi and Rolls, zip 89117, and that says wonderful sushi restaurant. If we look down here, another wonderful sushi down here. Yep. So these are all records that mention wonderful sushi in their output. So that's it. In a few easy stages, we've produced a microservice that will allow us to do searching on location and full text within a data set.